but to explain with terms of real life scenarios where the sequence of movement helps us to perform tasks. Let us take this example. When you run a marathon, you run along a curved line where you have to plan continuously the next sequence of movement that would prevent you from going straight. Instead of that, you make a curved turn. And this is only possible because of cerebellum. So the plan of running along the curved track is given by the cerebral cortex, which we all already know by now. And now what next happens is the sequence of movement, which is supposed to be created by the cerebellum, is stored in the lateral zone of cerebellar hemisphere. This is a sequence of movement which helps the person go along the curved path, and it is already created inside the cerebellum before the movement has occurred. Okay, so the sequence of images, like we are seeing the transition of one image to another, led to a framework of different images creating an animation. Same way, the different set of motion, one screenshot at a time, which was taken by the cerebellum, which was predicted and stored in the lateral zone of cerebellar hemisphere, is now ready with the cerebellum. This stored information will be sent continuously before the task has occurred, and that helps the person to run along the marathon smoothly, efficiently, without the constant inputs from the cerebral cortex. The cerebellum has taken over, and it's constantly sending the sequence of movement, which it's already synthesized, stored, and now it is giving the motor outputs to the muscles of the legs and help the person to run along the curved task without any interruption. And this mechanism is also called as servo mechanism, which is nothing but a feed forward type of mechanism, which means nothing but a type of response which was generated by an object without the stimulus.